Hello everyone, this is Suraj and today I'll be speaking on the topic applications on binomial distribution and Poisson distribution. The binomial distribution is a statistical probability distribution that summarizes the likelihood that a value will take one of the two independent values under a given set of parameters. The underlying assumptions of the binomial distribution are that there is only one outcome for each trial, or the trial has the same probability of success, and that each trial is mutually exclusive or independent of one another. It is a common discrete distribution used in statistics as opposed to a continuous distribution such as normal distribution. This is because the binomial distribution only counts two states, that is by 1 or the 0. 1 represents success and 0 represents failure. Given a number of trials in their data, binomial distribution thus represents the probability of X success in n trials, given a success probability P for each trial. The binomial distribution has various applications in CSE fields. Here are some of the examples. First is the error detection and correction. As we know that errors can occur during transmission of data or storage of the data. Thus, this binomial distribution can be used to model the probability of detecting and correcting errors using error detection and correction codes such as Party code, Hamming codes, or Reed-Solomon codes. The estimation of the probability of correct data transmission, or to identify the required level of redundancy for error correction, is done by this binomial distribution by various types of engineers. Next is the quality control and testing. The binomial distribution can be applied to quality control and software testing processes by software engineers. For example, when an engineer is conducting an acceptance testing where a software system is tested against specified requirements, the binomial distribution can be used to model the probability of passing or failing a certain number of test cases. The reliability and the quality of the systems is allowed to test by the software developers with this. Next is the A/B testing. The web development and online marketing uses this to compare the performance of two versions of web pages or applications. This can be utilized to analyze the results of A/B tests, where the number of conversions of success in each group is modeled as a binomial random variable. It helps in determining the statistical significance of the observed differences and making informed decisions about which versions performs better. Next is a reliability analysis. In this, the probability of success or failure of components or systems is decided over time. This is also used and employed in reliability engineering. By understanding the binomial distributions, they can estimate the reliability of a complex system and assess factors such as failure rate, system redundancy, and maintenance strategies. The binomial distribution can be utilized to model the probability of success or failure in various scenarios. In this, the analysis and capacity planning has to be done. This is known as performance analysis. For instance, in querying theory, the binomial distribution can be used to estimate the probability of a system being in certain state. Either the server is being busy or it's sitting idle without doing any work. Based on the arrival rate and service rate, the system performance and resource allocation aids in the optimizing system. Next is machine learning. In machine learning, the binomial distribution is employed in various algorithms and models. For example, a logistic regression, which is used for binary classification tasks, the binomial distribution is used to model the probability of belonging to a particular class. The maximum likelihood estimation based on the binomial distribution helps in training the logistic regression model. There are a few examples that highlight the application of binomial distribution in computer science field. The binomial distribution provides a powerful tool for modeling and analyzing probabilistic events in various domains, allowing engineers and researchers to make informed decisions to optimize the system performance. Next, coming to the Poisson distribution applications. So, what is meant by the Poisson distribution? It is technically defined as a discrete probability distribution for the counts of events that occur randomly in a given interval of time or space. Researchers have observed that most Poisson distributions are unimodal and display a positive skew that decreases as the mean number of events per interval increases. But in general terms, the Poisson distribution can be described as a form of probability distribution that uses discrete values or variables to show the likelihood of a specific number or events happening in a predetermined interval of time and or space, even when these events are said to happen at regular intervals that are independent of time considerations for the last event. For example, a public health official may use records to show that the department receives an average number of 20 complaints per day from citizens who are unhappy with the public water system. However, if one particular day the public health official receives more complaints coming from a broad range of sources and arriving independently of one another, then it is reasonably assumed that the complaints received per day follow a Poisson distribution since an infinite number of complaints are possibly in any given day. From this description and example, it is clear that public health officials can use estimations for the Poisson distribution to evaluate the likelihood of a set of independent events or experiences taking place in a predetermined time frame and space. Overall, it can be concluded that the Poisson distribution is a useful application for statisticians when it comes to estimating the likelihood of a number of autonomous events occurring in daily research settings and experimental contents. Although the length of the interval or time frame is of immense importance in determining the probability of an event occurring, it is important to remember that an infinite number of events or incidences can take place in any specified time frame. The Poisson distribution has many applications in various fields of computer science field. Here are some examples. Network traffic modeling. The Poisson distribution is commonly used to model network traffic patterns. It can be used to approximate the arrival rate of packets, the number of requests to a server, or the number of messages transmitted within a specific time of frame. This modeling helps in network capacity planning, traffic engineering, and also the resource allocation. Next is querying systems. So the Poisson distribution is frequently employed in the analysis of queuing system. Queuing system, as the name suggests, a form of queue where customers or tasks arrive at a service facility. It helps to model the arrival rate of customers, the number of customers in the system, and the waiting time. By understanding the Poisson distribution, one can optimize system performance, design efficient scheduling algorithms, and predict waiting time in various scenarios. Next is the fault analysis. Even in the Poisson distribution, it can be utilized to analyze the errors or faults that are occurring in a software application or the computer system itself. It helps in modeling the occurrences of errors or failures, estimating the failure rate, and predicting the number of failures within a specific amount of time. It helps in reliability analysis, fault tolerance design, and also maintenance planning. Next is event simulation. In computer simulations, the Poisson distribution is used to model the occurrences of random events. For instance, in decreased event simulation, where the behavior of a system is simulated over time, the Poisson distribution can be employed to determine when events should occur based on their average rate. This is useful for modeling real-world phenomena such as arrivals of customers in a queue, packet arrivals in a network, or user interaction in a web application. The Poisson distribution also has an application on keeping a track or analyzing the number of visits to a website or the frequency of web page requests. The Poisson distribution is also applied in analyzing web traffic data. By modeling the arrival rate of web requests using Poisson distribution, one can understand user behavior, predict server loads, and optimize web server configurations to handle varying levels of traffic. Next is anomaly detection. It can be used in anomaly detecting systems to identify abnormal patterns or events that occur in a computer system by comparing the observed event frequency to the expected frequency model by a Poisson distribution. Deviation can be detected and flagged as anomalies. This is used for intrusion detection, fraud detection, and system monitoring applications. Coming to the last one, machine learning. It also has an application in various machine learning algorithms and models. For example, in Poisson regression, it is used to model count data and predict the occurrences of events. This is particularly useful in areas such as natural language processing, where word frequency or document occurrences are modeled using the Poisson distribution. There are some examples highlighting the applications of Poisson distribution in CSE. The Poisson distribution provides a powerful probabilistic model for events with a known average rate of occurrences, enabling engineers and researchers to analyze and make predictions about various phenomena in computer system networks and data analysis. Thank you everyone. I hope you understood all the concepts that I covered in this presentation and hope you enjoyed learning. Thank you.